commands are being executed, you will be able to see that. So you will be able to see a live description going on about the interaction factors. We go from a most abstract level to the most specific level, trying to understand the characteristic one by one, which makes us understand how the sequence can be arrived, how the sequence will be taking place, and what are all the factors that we have to look into it. Good morning and welcome to the session 2nd in Unit 3, 5th semester Software Engineering for BCA, where we are going to talk about system modeling. Now, in the second session, we are going to look into something more interesting rather than the contextual models. Why? Because we are going to get into this tabular description of how the actors, the description, the data, stimulus, response and comments, I've looked into it. Now let's take an example here, a use case example of patient record system. This we are going to talk about a healthcare. So in this, we are going to look into who are the actors and how the data is going to be transferred. So let's first start with the medical receptionist, the patient record systems. These are the actors that are going to come in here. Then we have the description that is coming inside. What is the description? A description is where we are going to talk about the data. So the receptionist may transfer data from the MHC, which means to say that the medical records there, from to the patient record to a general patient database that is maintained by the health authority. This information is transferred, either it's updated to the personal information, address, phone, and it is used for the patient's diagnosis and treatment. Now, followed by which the data, what is the core data here? Patient's personal information and the treatment summary, followed by the stimulus, that is the user command issued by the medical receptionist. The response is confirmation that the PRS has been updated. Then we go to the comments. In the comment section, what you would be writing is that the receptionist must have appropriate permissions, proper security permissions to access the patient information as well as the record system. So now you can see the flow that is coming on there. Followed by which we would be talking about the next factor where we are interested in terms of the sequence diagram here, because the sequence diagram is very important for us to know. Why? Because the sequence diagrams are a part of the UML and they are used to model the interactions between the actors and the objects within the system. So this is very, very important for us. Now, in a sequence diagram, it shows us the sequence of interaction that takes place during a particular use case or an user instance. So you're going to learn at level 1, level 2, level 3, what is the kind of interaction that is going on between the users. Followed by which the objects and the actors who are listed involved, but primarily in the top of the diagram with a dotted line drawn vertically from this. Followed by which we are going to talk about the interaction between the objects that are indicated with annotated rows. So this is what we are going to see in terms of the sequence diagram. So you are able to see the overall picture of how the flow is going to be in terms of this data. Now, moving forward, I would also like to take upon the factor called as the structural models here. So what are the structural models of the software that we are going to talk about? Now, a structural model of a software will display organization of a system in terms of the components that make up that system and the relationship. So the key word here is the system and their relationship. So that's exactly where we are talking about the software components coming into picture. Why? Because in a structure, we need to identify the relationship between the factors, the system and their who are going to interact with each other. In a structural model might be a static model. This is not dynamic. Why? Because once we define a structure, we don't go much about changing it again and again. But suppose it's a dynamic model, assuming that we are going to bring in some dynamic picture into it, which will also show organization of the system when it is executing. So this is also important. Why? Because if it is a dynamic organizational model, that means each and every step in which the data is being executed, the commands are being executed, you will be able to see that. So you will be able to see a live description going on about the interaction factors. Now you create a structural model of the system when you are discussing and designing the structure, that is the system architecture altogether. Why do you do this? Why? Because once you have discussed, you have come across the various points that are needed, what would be the finer aspects of it, then you start getting into the structural models. Now, once we are finished with the structural models, we need to start looking into the next aspect about the class diagrams. Now, why are class diagrams used? Because they are used when developing an object-oriented model to show classes in a system and associations between these classes. Now, this is very, very important because what are the classes? Public class, private class, what are the types of classes that we are going to use? And there should be some association, there should be some meaning, there should be some relation, there should be some link between these systems. Now, an object class can be thought about as general. Now, when you are talking about object class or a character class, the definition of one kind of a system object, which is very much important here. An association is a link between the classes that indicates some relationship between the classes. So if the object is going to be, let's say, the patient, the relationship to that patient would be the medical records. So now what is going to happen? We are going to define certain relationship so that we identify the actors, we identify why they have been brought into picture. So when you are developing models during the early stages of software engineering projects, objects represent the real world, such as a prescription, a patient, a doctor, as I was trying to tell you. Now, let's say a doctor here, for example, is the object. The doctor's immediate relationship would be the patient's medical record, the past history, or about the hospitality, about the hospital functioning or his specialization, the way the treatment has to go through, the follow-up. So we first go on with an abstract level here in terms of first putting at the early stages what are all the objects, and then we try to connect the objects to the related systems. Followed by which, once we are done with the class diagram, then we need to understand the key points. What are the key points here? A model is an abstract view of the system that ignores the system details. Definitely yes. Complementary system models can be developed to show the system's context, interactions, and other factors. Context models show how a system that is being modeled is positioned in the environment with other systems and processes. Now, whenever we talk about an abstract model, that means to say that we have not gone into the detailing aspect. So what we have tried to do is we have only tried to give an overall system ideology altogether. We have not given a complete picture. We have not given a complete idea of how things are going to work, why it is needed, how it is needed. No, we are not going to get into all those factors. We are just trying to give a very, very brief picture, a very brief idea altogether as how these things are working for us. So this is definitely essential for all of us. Why? Because this will help us to understand better, what is the overall picture. The skeletal view of the project is easily available for them in terms of understanding this particular activity. Now, moving further, let me also talk about the use case diagrams, which are becoming highly essential, useful for us, because they are the sequence diagram. They describe the interaction between the users in the system that are being designed, and they would also actually help us to tell the sequence diagram movement. And use case is primarily an example that I would like to teach here, that I would like to tell out here. Why? Because every time it is not easy for us to just give a theoretical description of what is going on with the system and its interaction. A use case would be rather easier for us to understand the situation better. So when I talk about patient and the medical record, doctor and his way of treatment, this can be easily shown using a use case diagram where we can show the interaction between the system objects. So that's why use case diagrams are important. Followed by which we have also spoken about the structural models which show the organization architecture of a system. Class diagrams are used to define the static structure of the classes in a system and their association. So this is very, very important for all of us. Why? Because this will actually tell whether we are able to understand the structure factors, what are they associated, how they are working. Now, moving forward, we would also like to talk upon the generalization. Now, what is a generalization? Generalization is everyday technique that we use to manage complexity. Rather than the detailed characteristics of every entity that we experience, we like to place some general classes like animals, cars, houses, and learn the characteristics of these classes. Now, it's quite important and interesting for us at this juncture to understand generalization from a software engineering purpose. Now, let's say that we are developing a software for an automobile, for a car. Now, what happens is that all the cars have got many things in common and they also have got certain specific characteristics. The moment when I say a car, definitely it will have four wheels, it will also have a steering wheel, it will have an engine, it will have a bonnet. There are certain factors which appeal common to all of us. So generally, when I use that word car as a term here, I am trying to represent certain aspects that are commonly understood by each one of us. So here what happens is that let me first generalize the concept, learn about it in detail in the coming sequences, in the coming activities altogether. Now, what does this generalization do? This allows us to infer that different members of these classes have some common characteristics. Like here we have used squirrels and rats are rodents, for example. So moment I classify animals or cars or four-wheelers or two-wheelers, three-wheelers, when I put them into a particular category altogether, so it becomes a specific group by itself, and then we start delving deep into the group in terms of understanding their characteristics better. Now, moving forward from the generalization factor, we also try to understand it in terms of system modeling by using this factor, which is used to examine the classes of the system. If there is any scope of generalization, if changes are proposed, then you do not have to look into all classes. Rather, you just have to look that is affected by the change. Similarly, in an object-oriented language like Java, generalization is implemented during the class inheritance built into the language. Now, when we get into the system modeling and when we are talking about generalization, there's definitely a scope that we look into. Why? Because we do not want the entire system to get affected at the beginning itself. We go from a most abstract level to the most specific level, trying to understand the characteristic one by one. Similarly, we also try to understand what are all the related features that are needed for the project that would actually get in sequence in line with that project, and then we would try to connect ourselves in terms of doing that particular project. So when we talk about an object-oriented language like Java, the generalization is implemented during the class inheritance itself. So when you are inheriting that class, automatically there are certain generalized features which would be taken into it. So that's why I would always say generalization is an important aspect as we speak about in terms of the system modeling. Now, moving further, let us talk about this factor called as the attributes that are associated with higher level classes, also associated with the lower level classes. So generalization is not something that I would like to talk about like a 50,000 feet above this land, but this would also talk about the factor when I'm talking at the ground level also. The lower level classes are subclasses inherit the attributes operations from their superclasses. These lower level classes add more specific attributes and operations. Now let me just highlight it. Let me talk about it for a minute. When I say the lower level classes, that means to say that from a car, when we come down and we say that, yes, that is a sedan type car, or when we say it's a coupe kind of a car, or when we say it's a normal car which is less than 1500 cc or 1000 cc car, then automatically when we come down in terms of that lower attributes here, I'm getting into more specifics, more detail that will actually help me to develop a better software that is needed for that particular project, for that particular level of operation. Followed by which, when we have completed on this generalization, we will also talk about object class aggregation and modes. An aggregation model shows how classes or collections are composed of other classes. So, when I talk about this is a composition of other classes coming into picture. Similar part of relation in semantic data models, so which are related to each other. So that's where that semantic data models are coming into picture. Now, this aggregation model will show that these are certain things which are collected like a cluster kind of a factor that comes into picture. Now, moving forward, we also talk about the behavioral models as we were talking about it. So this would talk about the behavior of the system as executing, as it shows how it happens, what is supposed to happen, how the system responds. You can also think of these as stimuli of two types. Data, some arrives so that it has to be processed by the system. There are some events that happens that triggers the processing. So events are also associated here. Now, moment I say behavioral models, the first thing itself is that it's a dynamic in nature, and as it is executing, you will be able to show what happens or what is supposed to happen when that particular command, when that particular sequence of steps have to be taken fact. So moving from a static model like a context diagram, when we come to the behavioral model aspect, we are into the dynamic part of software engineering, which makes us understand how the sequence can be arrived, how the sequence will be taking place, and what are all the factors that we have to look into it. Now, moving further, we'll also talk about a data-driven model that shows a sequence of actions involved in processing the input. Now, primarily when I say that a data-driven model, every project, every system is driven by data. We are not going to run any project without data. So every model, every system that we are talking about will have a data primarily built in. So that is quite relative, quite understandable for all of us, because that is there. That is an inbuilt process and it keeps on happening altogether. Now, they are particularly useful during the analysis of requirement, as they can be used to show end-to-end processing of a system. So as the data flows through the project from one part to another, you will be able to understand how the sequence keeps on moving in and what are all the factors that are connected here. The data-driven model tells you what is the usage pattern, at what level the data is flowing from one system to another system, and what are all the steps that are involved. So that's why I say the processing of input data to get the associated output. Now, with that, we will move on to the next one, where we come about the event-driven. Event is something, when I talk about real-time systems, where it offers a minimal time and data processing that we are. Now, what happens here is that, for example, a landline phone switching system responds to events such as receiver off hook by generating a dial tone. So it is instant. In that very moment, that very second it has to happen. That's what we call it as a event-driven factor. Event-driven modeling shows how system responds to external and internal factor. It is based on the assumption that system has got a finite number of states and events may cause transition from one state to another. Now, this is very important for all of us to learn. There are finite states, which means to say that given a specific number of states, given a specific number of conditions, only within that the system will operate. So if you're going to talk about an infinite volume there, no, it's not going to work that way. We assume that this is well-defined boundary and the system will keep moving only within these boundaries. So whatever changes that are happening are pretty much well-defined and they will move from one step to another within that particular range only. So that's why we are bringing in this event-driven, which means it happens on that particular time, on that moment, and then we start looking at the actual event. Followed by the state machine models. Now, whenever we talk about the state machine model, it's a behavior of the system response to external and internal systems. It shows the system responses to stimuli often used for modeling the real-time system. State machine tools how system states and the nodes and events arcs between this node. So when an event occurs, the system moves from one state to another. The state charts are integral part of UML and they are used to represent the state machine model languages altogether. Now, this is where, when I say a state machine, I'm just going to talk about the machine, which is going to talk about response to the internal and external environment. And this modeling is often used in the real-time system. So this is also very, very important for us. Now, the model-driven engineering, now whenever I use the word model-driven, that's where it rather talks about the program than the models that are the principal outputs of the development process. Now, what happens here is that the programs will start executing on the hardware or on the software platform, and then they are generated automatically from the models. Now, we can use different proponents and factors here. So when we are using a strong programming language here, the program itself will start becoming the executioning part altogether. So it will automatically execute the languages, whatever the commands, and then it will take forward in terms of the data operations. Now we are talking about the usage of the model-driven. Now model-driven will be the pros of that is that it allows the system to consider at a higher level. It will help in generating code automatically that is needed to adapt to various platforms and systems. So this is more dynamic and flexible in nature. Moving forward, we would be talking about the negative aspects. The negative aspects of this is that models for abstraction and not necessarily right for implementation. So every time this cannot be implemented on the spot, taking that this is the right kind of example or data coming into it. Savings from generating code might be outweighed by the cost. So cost factors sometimes might be also on the factors, and developing of translators for the new platform. So that is also quite a tedious and challenging factor here. Now with this, I come to the end of today's presentation. I hope and believe that all the factors that we have spoken in this session will be a great help for you both in terms of theory as well as in the practical walk of life. In the upcoming session, we would be talking about the system modeling from the different aspects, from the dynamic parts of it, so that you would be able to connect with the subject much better. But until then, stay tuned, stay blessed, have a great day. Thank you once again for joining me today on this wonderful session.